Find a power series representation for the functions given below and determine the interval of convergence. So the strategy in this type of problem is we factor the function completely until the function looks like 1 divided by 1 minus x, and then we determine the base and write the geometric series. The geometric series is convergent if the absolute value of the common ratio, which is x less than 1. The reason we use 1 divided by 1 minus x, because that is what we discussed in the previous problem, right? So in the previous problem, I said how I introduced how to represent 1 divided by 1 minus x as a power series. So let's start with the first problem. So when you see a function, one thing that I am thinking immediately is I would like to try to write 1 divided by 1 minus x in the form 1 divided by 1 minus r. So how do we do that? So we have what f of x equals to 1 divided by 1 plus x. So I want to get a minus r in the denominator. So to get the common ratio out, the only way to do it is to have minus r, or we use x, so we use minus x. So that is the only way to do it. And then this is a geometric series. And then what is the common ratio? The common ratio is the r is equals to minus x, right? So, and then we write the geometric series. So that is summation n goes from 0 to infinity. So we are not having x raised to the n. The r is negative x. Then we have negative x raised to the n. And then the negative and the x, we can split that into negative 1 times x. And then we apply the law of exponents. So n goes from 0 to infinity. We have negative 1 raised to the n, and then x raised to the n, right? So this is a geometric series. So geometric series. And then to make the geometric series convergent, we have to make the absolute value of the common ratio less than 1. So and then you use the absolute value, that is just the absolute value of x less than 1, and then the absolute value of x less than 1 is the same thing as x is between 1 and negative 1, and then the interval of convergence is this. So we have x from negative 1 to 1, and then in here, so this is convergence, and then this is divergence, this is divergence. So overall, the the interval of convergence is that x is between negative 1 and 1. All right. Okay, moving on to the next ones. So if you want to test the 2n, then you have to let x equals to negative 1 and x equals to 1 to decide should you include the 2n. So we are not going to do that in here. So let's move on to the next one. The next problem we have, number 2, we have f of x equals to 2 divided by 3 minus x. So first of all, this is a technique that you have to learn in this type of problem. So how do you factor completely? First, I am trying to compare this to 1 divided by 1 minus x, right? So the only way to get a 1 on top and 1 on the bottom is you take the 2 over 3 out. And then after you take that out, you have 1 and then 1, right? But you forced to change the x to x divided by 3. This is a technique that you have to learn in this lesson. It's a new technique that you have to learn, use in this type of video, in this type of problem. So that is the summation. N goes from 0 to infinity. So we are trying to write this function in a power series. So that is a 2 divided by 3, and then we have a x over 3, right? So x over 3, and then raise that to the n power. So this one, the common ratio, the base, you can just call it the base, is x divided by 3, right? So we say that the series is convergent when the absolute value of the common ratio is less than 1, and then that is the same thing as that is between 1 and negative 1. So this is x over 3, and then you multiply 3 on each side. So negative 3 less than x, and then less than 3. So now you draw the interval of convergence. So we have a line that represents x. So between negative 3 and 3. So we have an open circle and then open circle. So within this interval, the power series is convergent, and then outside of this interval, the power series is divergent. And then regarding should you include the -3 and 3, you have to test the endpoint when x is equals to -3 and when x is equals to 3, right? So when x is equals to -3, you have an alternating series. When x is equals to 3, the 3 over 3 raised to the n is equals to 1, so the sum is just equals to 2/3. So sum equals to 2/3 is a convergent, right? So that can be tested very easily. I will just leave that part to you. So this one, we say that the interval of convergence is -3 less than or equal to x, and then less than or equal to 3. So should you include that, you have to test what happened when x is equals to -3 and what happened when x is equals to 3. We have done a lot of this type of testing in the previous lesson, the power series. This thing can be done pretty easily in this type of problem because the power series is not too complicated. All right, so that will be the end of this video. In the next video, I will introduce one more example that is a little bit more complicated compared to these two functions. So I will see you in the next video. As always, if you think my instruction is helpful, let me know in the comment section below. Like the video, subscribe to my channel. Trust me, it is worthwhile coming back visiting my channel. So watching my channel is way better than reading the book and then doing all the works by yourself. All right, I will see you all in the next lesson. Signing out for this.